Good morning. So today's lecture would be volcanoes and other igneous activities. So I'm pretty sure you guys are familiar with the volcanoes, right? Okay, so let's talk about the Pacific Ring of Fire. So this red highlighted area, starting from the South America, then it goes to the north, it's the nearby Japan, Indonesia, and finally it ends in the New Zealand. So this Ring of Fire, now why is called Ring of Fire? The reason is because more than 90% of the world earthquake they occur in this area. More than 80% of the volcanoes they erupt in this area, and that is the reason it's called Pacific Ring of Fire, because all those earthquake and volcanoes are very, very active in these regions. Okay, and that is the reason we call Pacific Ring of Fire. So in exam, if I ask you what is Pacific Ring of Fire, so remember it is the region where you have more than 90% of the earthquake and more than 80% of the volcanic eruptions. And this is again the data I have shown you in terms of like how many earthquake happens in this area and what is the magnitude of those earthquakes. So if you see most of the earthquake is right in this Ring of Fire. Okay, so let's talk about the volcanic eruptions. Now, before we talk about the eruptions, I'm pretty sure you guys are familiar with the magma and lava, right? So magma are the molten materials mixed with gas inside the earth crust, and the lava is when this magma is ejected from the earth crust, those gases will be escaped, and finally the molten material is simply termed as lava. So basically, it's not a huge difference, but still the difference is simply the mixture of gas. So the characteristic of magma determine the violence or explosiveness of eruption of volcanoes. Okay, so basically what I'm trying to say is the properties of the magma determine how violent the volcano gonna be. Okay, and that properties depend on these three factors: the composition, right? So how the magmas are made up of, temperature, how hot or cold the magma are, and the dissolved gases, what kind of gases are dissolved. So above these factors actually control something called viscosity of the magma. Now remember what the viscosity is. So basically the viscosity is the measure of the material resistance to flow. What does that mean? So I'll just think of two examples: water and honey. So honey is very thick and it does not spread very easily in compared to the water, right? So that means honey has more viscosity in compared to the water. So the general concept is if some liquid is more thicker, right, that means it has more viscosity. I mean, this, you can take this as an, one analogy. But again, so if any liquid that resistance to flow, that is hard to flow, right, that has more viscosity in compared to the liquid that can easily spread on the floor. Okay, so what are the factors that that depend or describe or measure this viscosity? So these are the factors that measure the viscosity. So first is the temperature, of course. So remember the relationship. If you increase the temperature of these materials, the viscosity will decrease. So what I'm saying is if I heat this honey, then it will be thinner and it can easily spread on the surface, right? But again, if you decrease the temperature of this honey, it will be more thicker. So that means it will increase the viscosity. Okay, and the second one is composition. So when I say composition, I mean the silica in content. So if you have more silica in these materials, that means the viscosity will be higher. Now, of course, the silica, right? It's the small shiny material in the sand particles, right? It's more like silicate, but in silica you have only silicon and 2 oxygen. In silicate you have silicon and 4 oxygen, but it's kind of very similar. So when you have a more silica, that means it will increase the viscosity. If you have less content of silica, it will decrease the viscosity. So just remember the relation between the temperature and composition, especially in terms of silica content. Okay, then comes the dissolved gas. So the dissolved gas is one of the major factors that decide how violence the volcano gonna be. Okay, so again, I will describe this in more detail, but for now, I'll just give one example. Just take an example of soda bottle like Coca-Cola, right? So those bottle, those cokes are, mixed with some carbon dioxide gas, right? So when you shake those bottle, right, and you try to open the lid cap, they will explode, right? So it's the same analogy for the volcanoes. So inside the earth crust, your magma, right? So the molten material and the gas like carbon dioxide and water, steam, they are mixed and they're trying to expand. When they expand, they try, they produce more pressure on the surface, on the crust, and then if they find, if the pressure is more greater in compared to the the crust layer, they will explode in form of volcanic eruptions. Okay. So let's talk about the lava flows. Now, once you have a lava which is ejected molten materials, basically we divide this lava into two types. Okay. Now again, these are like Hawaiian language. So the first type is called something called Pa Hoi Hoi. That's how we pronounce this. So it's called Pa Hoi Hoi. That means it resembles a twisted or ropey structure. So if you see this lava, it has a ropey structure like a rope, right? And these lava are very like smooth, and that's why it's called Pa Hoi Hoi. That means it's very smooth. Okay. And the second types of lava flow is called AA. Well, this is pronounced as okay. So again, it's coming from Hawaiian language. So is simply represent a rough, jagged, blocky structure. So the second picture represent that this has a blocky structure, right, and very rough in structure. So this roughy structure represents lava flow, and this ropey smooth structure represent Pa Hoi Hoi. So just remember, in exam I might give you this to picture and ask you to find if it's a Pa Hoi Hoi or Again, the dissolved gas is about 1 to 6% by weight, and it's mainly water, steam, and carbon dioxide. So if someone asks you what kind of gas is dissolved in the magma, so the answer is water, steam, and carbon dioxide. All right. Okay, so this is the picture that represents the AA lava, which will be more like a roughy structure. Okay, then what are the material that's ejecting during the volcanic eruption? So the one of the important thing that you need to remember is called pyroclastic materials. So pyroclastic materials is actually defined as anything that's ejected from the or during the volcanic eruptions. Okay, so that's why it's called fire fragments. So again, what is pyroclastic materials? Anything, any kind of material that's ejecting during the volcanic eruption is called or is termed as pyroclastic materials. Now we divide like different types of pyroclastic debris. One is ash and dust particles. So you're familiar what is the ash and dust, right? It's a fine glassy fragments. Then come the pumice, which is like this picture at the top, which is a porous rock, which is very soft and frothy lava. And then comes the cinder cone, which is more like pea-sized materials. Then comes the lapilli, which is walnut-sized materials, and the more important one is which is called block and bumps. Okay, so this block and bumps is like may vary from like to a few centimeter. Like if you see the structure, this is like 2 centimeters. So this is like might be 6 to 8 centimeter in diameter. And these blocks and bumps are responsible for destroying the life and the infrastructure. Again, remember, bumps and blocks, they can travel like 100 or 1,000 miles in atmosphere. Okay, and these are the two major pyroclastic materials that destroy life and properties. So I want you to remember block and bumps. Okay, now let's talk about the volcanic structures. So basically, if you see a cross-section structure of the volcanoes, the outer part is called crater, which is also especially in the top of the summit, right? Now, if this mouth is less than 1 kilometer in diameter, we say crater. If this mouth, or opening is more than 1 kilometer in diameter, we say it's a caldera. Okay, so the difference between the crater and caldera is crater is less than a kilometer, and caldera is more than a kilometer. Then comes the vent. Vent are the small opening, right? This chamber, and then comes the femoral, which emits only gas and smoke. So if you see the small vent right here as well, so this vent will emit a gas, especially water, steam, and carbon dioxide. So one example is presented in this picture. So if you see these volcanic mountains, they emit this kind of gas, and these gas are called femoral. Okay, now we divide the volcano into three basic types. The first one is called shield volcano. So the reason it's called shield is because if you see, it looks like a shield, right? And then they're very flat mountains, and generally they cover large area and then produce mild eruption of large volume of basaltic lava. And one example is Mauna Loa on Hawaii. So these are the volcanic mountains. Second one is called cinder cone. So basically these they form in a group. So you will find like 2 or 3 volcanic mountains. They are located together. Now, if you see the slope, it's kind of steeper in compared to the shield volcanoes, and they frequently occur in groups. So just remember that. And the third one, which is the most dangerous one, is called composite cone. Okay, so again, the composite cone is the most deadliest volcano that we can find on our Earth. So the examples are Fujimaya, Mount St. Helens in Washington D.C. Sorry, not Washington D.C. So Washington State, and then come the Mount Vesuvius. So these are the like different types of composite volcano. Again, they are very steep in structures, and when they erupt in like thousands of feet high in the atmosphere. Okay, so the one example is called Pompeii. Remember, this is the Mount Vesuvius, which erupted in August like 2479 AD. And then I think there are so many movies on this called Pompeii. So remember this, when they erupted, nobody was aware of the eruption of the volcano, and it was so deadly eruption that everything had converted into the rock. They cast it to rocks because of that high temperature, and like almost like entire population, they perished, they died because of these volcanic eruptions. Okay, so this is also one important image for, especially you need to remember for the exam. So might be I'll give this picture, and I'll give some blank space right here, and I'll ask you to point which one represent what kind of pyroclastic materials. Okay, so for example, everything that's coming out is called pyroclastic. So these all are pyroclastic. The opening is vent, right, which is more like crater. Then comes these small dot particles. These are bombs. Okay, these are molten materials. These are called lava. Then comes so these are the lava. Lahar, I'll explain in a minute what the lahar is. Then comes the femoral, like the small vent through which the water, steam, and carbon dioxide are ejecting. So please go through this picture and try to get some basic types of, especially lava, bomb, the pyroclastic materials, lahar, and lava flow. Okay, so what is lahar? So lahar is basically defined as the volcanic mud flow. So especially during the volcanic eruptions, the mixture of volcanic debris and water, they mix together and they start to flow in it looks like like the flow like the river, but basically it's simply the mixture of volcanic debris and water. And this they move down stream valleys, and especially this motion of volcanic mud flow is termed as lahar. So this is one of the example of lahar shown in the St. Helens, which erupted in 1982 in Washington. Okay, so this was like some brief explanation of the volcanoes. So if you guys have any questions, just let me know, and I will set up like Zoom meeting, and where we can talk live. So yes, so please let me know through email, And if you have any question or concern, you simply can also, comment me on Canvas as well. I'll see you guys next time.